Brought to you by DK Audio.
DK Audio presents The Magic and Mystery of Space by Shoshana Weider. Read by Maguire. Introduction. Ever since I was young, there was nothing I found more awesome than gazing up at the night sky or a full moon and wondering about my place in the universe. I love that everyone can experience these same feelings by looking up to the stars, planets, and galaxies beyond our home. So come with me to explore the magic that space holds. We will journey back to the beginning of time at the Big Bang, through our solar system, the places where we might find other life, and much, much more. Shoshana Weider. What is space? Space is enormous. It contains everything that has ever existed, including all the planets, stars, and galaxies. It begins at the edge of Earth's atmosphere, where the air thins to almost nothing. This boundary is known as the Kármán line. The edge of space is often defined as being 100 kilometers, or 62 miles, above sea level. Space has fascinated people for centuries. Only a handful of people have ever ventured beyond the safety of Earth. The universe. The planet we call home seems huge to us, but it is just a tiny dot in the vastness of the universe. The universe is everything there is, including space, and stretches out further than we can imagine. It contains billions of stars, planets, rocks, and dust, but most of it is actually empty. So, how do we fit in? We live on a planet called Earth. So far, it is the only place in the universe known to have life. Earth is one of 8 planets in our solar system. At the center of the solar system is a star, the Sun. The Sun is one of at least 100 billion stars that make up a galaxy called the Milky Way. It is estimated that there are at least 200 billion galaxies in the universe. Most of space appears dark because there is nothing there to reflect light from the sun or other stars. Space has no air, so it is also completely silent, as sounds need air to be able to travel. On Earth, we measure distances using kilometers or miles. In space, those measurements are so small they are almost useless. So, we measure space distances using light years. A light year is the distance light can travel in an Earth year. Each light year is around 10 trillion kilometers, or 6 trillion miles. Earth is approximately 8.3 light minutes away from the Sun, our closest star. 4.3 light years away from Proxima Centauri, our closest neighboring star. 26,000 light years away from the center of the Milky Way, our galaxy. 2.5 million light years away from Andromeda, the nearest large galaxy. Light travels faster than anything else on Earth or in space. Studying space. Humans started sending missions to space around 70 years ago. But ancient records show that people have been studying space for thousands of years. There are many ways to look into space without leaving Earth. Keeping track. We can follow the movement of the sun, moon, and stars across the sky without using any special equipment. The earliest astronomers measured these movements and used them to track time and create calendars. Early telescopes could see only visible light, including the colors of the rainbow. However, modern telescopes can observe other types of light coming from stars and other objects in space. Telescopes use lenses or mirrors to make things that are far away appear bigger. They were first used to study objects in space in the 1600s. The earliest telescopes were small and simply designed. You would look through one end and point the other at the object you wanted to see. Astronomers can now use the internet to control telescopes from anywhere on Earth. The biggest telescopes are housed in big buildings called observatories. Today's telescopes that capture visible light can be more than 10 meters or 33 feet long, which is longer than a bus. They are often built in deserts or on mountains, where there are few clouds to block their views. Large telescopes give us amazing views of the universe, letting us learn more about space objects. The Big Bang. Scientists think that the universe began suddenly, almost 14 billion years ago. It all started with an explosion from an unimaginably hot and dense single point, which contained all the material in the entire universe. The universe has been expanding and cooling ever since, and the galaxies are now millions of light years apart. In the first second, time begins. The expansion of the universe began within the first second after the explosion, or Big Bang. At this stage, the universe was like an extremely hot soup of particles and light. During the next 5 minutes, the universe expanded and cooled enough for the atoms of the first chemical elements, such as hydrogen and helium, to form. After 380,000 years, the universe was cool enough that tiny particles, electrons, were captured into atoms. Light could now travel across the universe. Over the next hundreds of millions of years, lumpier areas pulled in more material. They got hotter and denser, forming huge, brightly shining stars. After 400 million years, nearly all the hydrogen and helium had become stars. They grouped themselves into galaxies, which we can still see today. After 9.2 billion years, you find our solar system. Our sun formed about 4.6 billion years ago. The material around it came together, forming our solar system's planets. And in 13.8 billion years is the future. Astronomers believe that the universe is still expanding and will continue to expand forever. This may be because of mysterious, dark energy. Our solar system. The solar system is everything that travels around our sun, held there by the sun's gravity. It includes the planets and their moons, asteroids, comets, and more. The sun's gravitational pull is strong because it's so big. The solar system is around 4.6 billion years old, but everything in it developed in different ways. This is why the planets, moons, asteroids, and other objects look different from each other. Scientists use clues from these objects today to help them understand the history of the solar system. Everything around the sun. It's hard to say where the solar system ends. Its edge can be defined in many ways, such as by the reach of the sun's magnetic field, or where its gravity no longer dominates space. But we are certain that the sun's influence stretches for billions of kilometers. Scientists split the solar system into zones to help us understand it. Most large objects in the solar system orbit, or go around, the sun on the same horizontal level, which is known as the ecliptic plate. However, some objects, such as Pluto and some comets, orbit the sun on different planes. In the inner solar system, you will find Mercury closest to the sun. The next closest is Venus, followed by Earth and Mars. Then you'll find the main asteroid belt. Beyond this, in the outer solar system, you'll find Jupiter, then Saturn, Uranus, Pluto, then Neptune, with the Kuiper belt beyond that. There could be another giant planet far beyond Neptune, but we haven't found it yet. The Oort cloud lies at the solar system's edge. It contains billions of icy and rocky bodies, and may be where many comets come from. It stretches almost halfway to the next star. The Sun. The Sun is an extremely hot ball of gas.
Sample complete. Ready to continue?